Hi, my name is John, and I will be going over Chapter 3 test for Charles B. McKeague with you. For the most part, most of the questions, except problems 41 through 52 all. So we're going to be going over 1 through 40. Okay, this is part 1. And so we're going to start with the process pretty soon. Number 1, draw 235 degrees. And name that reference angle. So theta equals what? Okay, so starting off, this is the x-axis right over here. Going this way is positive, up. You're going to hell, you're going down, you're going to hell. So this is the reference with the positive x-axis, positive and negative. Okay, so 90 degrees, 180 degrees, 270 degrees, 9, 18, 27. So it's definitely going to be in the third quadrant right over here, radiating out from the origin. So here it is. From the origin, it's radiating out in that direction. That's how you draw it. Find the reference angle. The reference angle always makes with the x-axis. So there's the x-axis. The closest one, you draw it up. So that's theta hat. How do you find theta hat? You take 180 degrees, subtract it from 235 degrees, and you get 55 degrees. That's theta hat. Theta hat right there, it has a little hat, that's called the reference angle. Okay. Number 3 now, do the same thing as well. 400, I'm going to use a little bit different numbers, like 487 degrees and 10 minutes. 487 degrees and 10 minutes. And I want you to figure out what that is in drawing it out and the reference angle. So if you draw a whole circle, is 360 degrees, so that's 360 right there. That's 450 degrees. It's going to be a little bit past 450. This is going to be 500 at 90, 40 degrees. So it's going to be in quadrant 2 somewhere, radiating out from the origin. So there it is. We drew it out. Of course, we have to find theta hat. First thing we do is subtract 360 degrees from 487 degrees and 10 minutes. And you get 117 degrees and 10 minutes. And so to find that angle, you have to go 180 minus that to figure out what that angle theta hat is. So 180 degrees minus 117 degrees, 10 minutes. Of course, you have to borrow 179 degrees, and one angle, 1 degree angle is going to be 16 minutes. Subtract it, you get 50 minutes. 9 minus 7 is 2, 7 minus 1 is 6, 62 degrees and 15 minutes, and that's equal to your theta hat or your reference angle. Okay. Use a calculator. Number 5, you should be able to do 1 through 4 by yourself then. Number 5, it says find the cotangent of 320 degrees. Of course, your calculator right over here does not contain any secant, cosecant, or cotangent. Only has a sine, cosine, and a tangent function. So what we have to do is change this into cosine, or sine, or tangent. The reciprocal of the cotangent function is a tangent function. So it becomes 1 over the tangent of 320 degrees. Don't forget to put my imprint. So I go straight on first. 1 divided by the tangent of 320 degrees. That should give me approximately negative 1.1918. Okay, and you can see part of it right over here. It's 1 divided by the tangent of 320 degrees. You should be able to do, for the most part, all of it, except for maybe number 9. Was the secant of 140 degrees and 20 minutes. Of course, to change this from a minute form into a decimal form, we divide it by 60. That gets rid of that. That becomes a secant of 140.2 over 6 is 1/3, 3 degrees. To find the secant, it's the reciprocal function of the cosine right there, the c. That's how you remember. There's only one c right there. Cosine of 140 degrees, 0.33 bar. So I go 1 divided by the cosine of 140.333, and I get approximately negative 1.2991. Okay, And so you should be able to do all of your other problems by through number 10. Let's try number 11. It gets a little bit more difficult at this stage, so I might do a couple of problems from this section. Number 11, let's start off with the problem. The sine of the angle theta is equal to 0.1045, and theta resides in quadrant 2. To find the reference angle, theta, right there, put a little hat over there, you take the absolute value. Of course, since 0.1045 is already positive, we really don't care. So theta hat is equal to the sine inverse of 0.1045. And just let's see our calculator for that. Everything's impromptu, so I have to do everything by hand. 0.1045, and you get approximately 6 degrees, 5.99. It's approximately 6 degrees. Now, since we found theta hat and resides in quadrant 2, you want to draw the reference. Quadrant 2, quadrant 1, quadrant 2 irradiates out from the second quadrant, into the second quadrant, and of course, it's referenced always with the x-axis, so therefore, that's theta hat right there. That's approximately 6 degrees. So this, from your positive x-axis, is positive. You're going to heaven, going up, going down, you're going to hell. So if it's negative, you're always going down towards hell. So since theta hat, the reference angle is 6 degrees, theta, right there, is equal to 180 minus that is 174 degrees, approximately. Okay? So let's do a little bit more difficult problem, like number 12. Or 13. We'll actually do 12 and 14 as well. 12, they give you the cosine of the angle is equal to negative 0.4772, and theta resides in quadrant 3. I'm going to check my work on this one. I know I didn't check my work on this one, but we're actually going to check your work and show you how to check your work on this one as well. Problem number 12. So, of course, we do the same thing again. We take the reference angle, theta hat, you take the absolute value of that to find your reference angle. So, cosine of theta hat is equal to 0.4772. Absolute value of a negative number is always positive. Absolutely. And so theta hat is equal to cosine inverse of 0.4772. And then I use my calculator to figure out what that is. Cosine inverse of 0.4772. And what do I get? 61.5 degrees. 61.5 degrees. So what I'm going to do here, before I get to my calculator a little bit, it resides in quadrant 3. So here's quadrant 1, 2, 3. It radiates out from the origin. And don't forget, this is theta hat right here. 180 degrees plus 61.5 degrees. So theta is approximately 241.5 degrees because we add 180 to that. 180 plus the reference angle will give you 241.3. So we add 241.3. I'm sorry, add, excuse me, 180 degrees. And you end up with, of course, 241.5. So how do we check our answer? We take the cosine of the original problem, theta of the answer. Here's my answer key right over here. If you can see a little bit better, here's my answer key. Take the cosine of the answer of 241, we should get exactly negative 0.4772. And if you can see it right over here, it is exactly negative 0.4772. Okay, so we checked our work. We physically put a little check right there because we checked it. 9 minutes has elapsed. We'll do some other problems. That was number 12. Let's do number 14 first. 14 says the secant of an angle is equal to 1.545, and theta resides in quadrant 4. Okay? It's a little tricky. Don't worry about it. We do the same thing again. We take the reference angle, we take the absolute value of it, and so you end up with the secant of the reference angle is equal to 1.545 again. We don't know how to do that because there's no, on the calculator, there's no secant function. So we take the reciprocal function, 1 over the cosine of the angle, reference angle, is equal to 1.545. At this stage, you can flip the left side, flip the right side. If you're not sure, just put it over 1. Flip the left side, flip the right side, you should get cosine of theta hat is equal to 1 over 1.545. And how do we find the reference angle? Of course, we take the cosine inverse of that, 1 over 1.545. And so we're going to use our calculator at this stage. Cosine inverse of 1 divided by 1.545. And we should get approximately 49.7 degrees. 49.7 degrees. Notice that it resides in quadrant 4. So we actually, since we find the reference angle, 1, 2, 3, 4, radiating out from the origin, that's equal to theta hat. So this is the actual angle, theta. Starting at 0, it goes all the way to 90, 180, 270, and then it's going to be somewhere in the 4th quadrant, because it said so right over here. So how do you find that out? You take 360 minus the answer, not plus, minus the answer key right here, and it turns out to be 310.33 degrees. And I use the exact value, so I'm actually going to work it out, check my answer. How do I check my answer? I plug it into the original equation without the theta hat or the highlighted marker. So 1 divided by the cosine, that's a reciprocal function for the cosine of my answer. I should get 1.545. Back. One more time. What am I going to go to? Oh, did it again. 1 divided by the cosine of my answer. And I get exactly 1.545. Okay, if you can see that or not. So it checked out. Perfect. We'll do maybe 1 or 2 questions more before I get into the second portion. Let's do number 15. Find the exact value of the sine of 225 degrees. First, we have to figure out that's the angle theta right here. We have to figure out what theta hat is, the reference angle. So we draw it out. 190, 180, 225 is located right here. It makes a reference with the x-axis. If you work at it, that's 180 right there, subtracted. 180 subtracted from 225, you get 45 degrees. So let's draw it out, the triangle. That's 45 degrees, that's your reference angle. You draw it up to the x-axis, and it's a 45, 45, 90. This is -1, this is -1, this is root 2. 1, 1, root 2. Don't forget to put your minus negatives on these. Once you get your negatives, you can actually just figure out what the sine of that angle is. The sine is the opposite over the hypotenuse, SOHCAHTOA, the y value over the radius, same thing. It's going to be sine of 225 degrees is equal to -1 over root 2. That's also, if you rationalize the denominator, root 2 over 2 negative, also approximately 0.707 negative. So there it is. If I actually take the sine of 225, I get approximately -0.707. Okay? So if you get approximately 0.707 on your answer, you know the exact value is going to be root 2 over 2 with the negative in front. And we'll stop here. We'll go to part 2 later.